Then let me know when you want your... So I can... Yeah.
Alright, so
I'll
I'll just
grab
hold
this.
this.
You can hold the mic.
Yeah.
Oh yeah, shucks. I need to speak through the thing first, then I click on the... Yeah. Okay.
Or you click that one on her also.
Oh, but she'll use the mic to answer more questions later.
Okay.
So I think better... Oh, we can just take turns.
No, you click. Oh, okay, yeah. Then
Yeah, I
I
think-
still cannot this one. I still cannot.
Yeah. Okay. 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 Wait. Yeah. Comfortable?
I guess can.
Hello. Yeah, cannot, because this thing is like just not in that it moved. I was
it
like, oh my
moved,
god, yeah, no. Okay. Hi everyone. Yeah, can I get your attention? Thanks for coming. I think we'll start. We won't wait. Hello. Yeah, sound. Hello. Can you hear?
Can you hear?
Can everyone hear me fine? I think I'm quite loud, so I think it should be okay. Yeah, if you've just arrived, you can please feel free to make yourself feel comfortable. QR codes on the table, and the menu is also on the table. So welcome everyone to Wild Conversations. We are at a new venue. Thank you for showing up at the right place, because we were so afraid everyone's going to turn up at the wrong place. But thanks for finding us and arriving on time. So what is Wild Conversations? So for our new friends who have joined us, Wild Conversations is a series of casual conversations. So we encourage you to ask questions at any point in time. So please just raise your hand. It's very casual. And it's on topics related to biodiversity and nature and sustainability. What we want to do is to foster a community that cares for these planetary issues. So we want to thank our venue partner, Nude Seafood, for hosting us here. They have a great selection of food and drinks that you can find on the menu. So please order away. And also please eat. We want to thank our videographer and photographer, our entire team here, for making this happen. Thanks, guys. And also, Wild Conversations is actually a free to attend conversation. So while we don't charge, we typically will ask the speaker to pick an organization for people to contribute to. We want to raise awareness for other organizations, and our speaker has chosen Mothers in Science, which she's also a representative of. So what is Mothers in Science? Mothers in Science is a non-profit organization advocating for mothers in STEM. So STEM is, anyone knows what STEM is? Science,
technology,
yeah,
engineering, maths.
and medicine. Yeah, so STEMM. So it's to encourage equity and inclusion for parents and caregivers. So I will pass this around for you to make your contributions if you like. So I'll just, feel free to kind of like pass it around. Okay, so let's start. I'll do a short introduction of our speaker. I think most of you would have read and know her, but I think I'll just make a quick introduction. So we have Dr. Mei Lin. She's also known as Giant Clam Girl at St. John's Island National Marine Laboratory. She's been fascinated with giant clams for a really long time, and she spent a decade doing her research on it. So she's also published a book called A Field Guide to Giant Clams of the Indo-Pacific. And in addition to her full-time job, she also represents the non-profit organization Mothers in Science, helping to build awareness and support for fellow science moms. So that's Dr. Neo here with me. Can we give her a round of applause? Thanks, guys. Okay, so typically what I'll do is I want to find out how much do the audience know about this topic. So I usually will have a quiz question for you guys. Okay, let's start. Just shout out your answers. How old do you think the oldest clam in the world is? So I'll give you options A, B, and C. A is 77 years old. B is 107 years old. And C is 507 years old. So how old is the oldest clam in the world? Make a guess. C, B, C. 500. Yeah, so surprisingly, it is 507 years old. It's incredibly old. I was very shocked to find out myself. Oh. Is it? Oh, unfortunately.
Yeah. So it's like
Yeah.
that's the end of the age.
Oh, okay. So second question. How big can giant clams grow in size and weight? Okay, so I'll give you 3 sizes and weight. Yeah, so size. So we go by width. 1 meter and 250 kilograms. 2 meters and 350 kilograms. And 3 meters and 450 kilograms. So is it A, 1 meter, 250, B, 2 meters, 350, or C, 3 meters and 450? What do you think? B. How many B's? Raise your hands. Oh, okay. How many? Any other answers? No, only B. Only A. A, okay. And then C. Okay, so we have A, B, and C, but majority B. Damn, wrong. Okay, it is A. It is 1 meter and 250 kilograms. But still, it's pretty big and pretty heavy. It's pretty massive clam. Yeah. Okay, third question. Third and last question. How many eggs can a giant clam produce at any one time? How many eggs can giant clams produce at any one time? A, 5 million, B, 50 million, or C, 500 million. So how many eggs can giant clams produce? 5 million, 50 million, 500 million? Make a guess. A, raise your hand. Okay, 2. B, raise your hands. Wow, 5. C, raise your hands. Nobody for C. All right, the answer is, drum roll, it is actually C. 500 million eggs. So giant clams are also hermaphroditic, which means that they produce both egg and sperm at the same time. And I'll let you explain a little bit more about it. Okay, so without further ado, I'll start off with several questions that maybe Mei Lin can help to share. I'll pass you the mic and then I'll hook on the other mic. Okay. Yeah, okay, so I'll start with the first question. What is a giant clam, and what is the difference between a clam, oyster, mussel, scallop, and any other clams that are?
So hi everyone, good evening, and really nice to see some of your familiar faces as well. But before I answer, I want to really thank Daphne and Wow Space for inviting me here to have this casual conversation. So what exactly is a giant clam? So maybe before that, maybe the word clam itself is very loosely used as a very common terminology that everyone uses. So whenever you see animals with shells, you would just say oh, it's a clam. So when you see even a mussel, an oyster, or the lalas that you like to eat in your barbecue, you immediately come to mind that these are clams. But what gives them those different names is because of their shapes and sizes, and how they generally look to you. So I think mussels, oysters are one of the few easiest ones to recognize. But when it comes down to say the different lalas that you're eating, what I call them Venus clams, and many different types of names as well, they start to look very similar to you, and you're like, okay these are just clams that I eat. Whereas when it comes to the giant clam, the name itself doesn't give you too much sort of an idea what it is. So if I may have one of the photos to show.
Sorry, we'll go to your slide.
It's okay.
Yeah.
So when you first see this animal in the wild, or when you see a photograph of it, it doesn't really strike you as a clam. So this is how it looks like in the wild and in the natural environment. It's just very colorful looking animal, very fleshy. It's unlike any of your clams that you've eaten or seen before, because this animal has a sort of a very unique body structure where the soft tissue is mostly on the outside. So it actually extrudes a lot of its soft tissues outside, and then the shells would just be surrounding on both sides. So this is unlike any of your others. In the mussels that you see, most of the meat and flesh is inside, which makes sense because the shells are hard and they help protect the animal. Whereas this animal has formed different defensive mechanisms, but the one main reason for it looking like this is because they rely a lot on sunlight. they are what I like to call solar-powered animals. They actually have very special relationships with a very small microalgae plankton, where it helps them it photosynthesizes, and it helps provide food for the clams. And that also partially explains why this particular species can grow to such large sizes compared to like your usual mussels and oysters. So in the book that I wrote and with a student of mine illustrating it, I decided to sort of like show the animal in this way. So it gives you an idea that you're actually looking at the shell separately, and this is the soft tissues that you see here. So imagine if you actually dissect the clam, it would look something like this. Yeah, and it's pretty different from the mussels and oysters. But because you don't get them in the market, so it's probably very hard for you to go do dissection. But if you have the chance of looking at mussels and oysters, you would realize that they are very, very entirely different.
Okay. So is this species the only one with the extruding
tissue.
flesh? Yeah, tissues? Yeah.
It's one of the more prominent ones. And it's also particularly more enlarged because they want to basically have it's a bit more of a physics, like increased surface area of the tissue, more sunlight, and it can grow faster, it can grow bigger.
Okay, I see. Interesting. Okay. So any questions about clams, oysters, mussels, and lalas that you eat? No? All good? You understand the difference now?
Yes.
Are you
Yeah.
explaining the defense mechanisms they have instead of the shell?
So he asked are you explaining the defense mechanisms of the giant clam
Oh, I see.
instead of just the shell, because it doesn't, it's like more tissues
Yes.
than shell, I
Yeah,
guess?
sure, certainly. So I think when you first see them in the reef, like it's really very colorful. So it actually does match very well with the background in general. So in fact, an animal this big, you can also swim by and miss it completely. Unless it moves slightly, then you realize that, okay, there's a clam under me. But in most times, even myself as a trained scuba diver or like, a clam scientist in this case, I still find it difficult to actually locate them on coral reefs. So that's one of the, I would say, natural defense, being very similarly colored to the background of the environment. But the other is that, for an animal this big, like it can squirt water really very well at, like, maybe not us because we're not very easily deterred. Clearly we are like one of the main threats to them. But like, when fishes swim by or like big animals swim by, they would actually just like very immediately shut their shells, and it actually propels a very strong jet of water that kind of like, chews away anything that surrounds them. Yeah, but when they're so big, like very few animals really can eat them. So most of the defense mechanisms or the protection, how they protect themselves are when they're a lot smaller, like when they're like baby clams. So baby clams can walk around. So like on a floor like this, they can walk around and then find places to hide. They also, some species have like additional shell structures that makes the shell a little bit prickly. So when a fish tries to bite them, it will basically be a little bit painful for them in the jaw. So they might spit them out, and then like it might get away as well. Yeah. So these are just some ways.
Oh, okay. And if they have no natural predators in the wild, so what would you say are the main, like, I guess, threats to them? I guess also being eaten when they're small is one.
Yeah.
But when they are big, are we saying that there's basically no kind of predators, I guess, for them? Threats?
Yeah, I think that there are still some. But it doesn't. We don't really usually see like them dying because of the predation. So for example, like the flesh is really tasty because it's packed with like microalgae, which is very nutritious for many animals. So we actually have fishes pecking at them. But because they only pack like certain parts of the tissues, so we do see fish bite marks. We mostly fish bite marks, but definitely also other animals like crabs, but because they only nibble very little, so these animals can actually tolerate.
quite
So it's a bit
hardy.
So it's a bit like imagine your hair get trimmed off every few months. Whereas like maybe hair is not so bad for us because it's not so painful, but for them, what we've learned in our lab is that they can actually regenerate their tissue. So the places where they've been bitten, they can actually regrow the tissue, which is something very amazing. And we realized that it's not only just giant clams, but some other what I call bivalves, because bivalve shells species, have that ability as well. Although it still takes about 90 days, which is still pretty long. But imagine if you have an injury, you would still need time to recover. So 3 months is pretty good for them.
Okay. Oh, very interesting. And you said that they can walk. How do they walk, actually? It's just like...
I don't know if I have a video. Do I have a video?
Is there a video?
I don't know. To check which slide, if I might have. No, I don't think so.
No video.
Maybe I can go to slide 3 just
Slide three?
to
Yeah.
show like sort of the life cycle
Yeah.
and where I was talking about like the movement.
Yeah.
So this is the general what I call life cycle. It's pretty short. So for an animal this big, it takes about 9 days to 14 days to become a miniature version of themselves. It's pretty
9 or 14 only?
Yeah.
Oh, that's quick.
Yeah, it's pretty fast. But when they're like 14 days old, they're still microscopic, probably no bigger than some of the rice grains that you have on your
that's
dinner plate right now.
small. Okay.
So for them to actually survive until they reach like, a meter long or half a meter long, it takes decades. And it takes a lot of effort for them to like avoid predators and then, really become like the fittest of the batch, right? But at this size, they are very, very mobile. So like what Daphne was asking, like how do they walk? So the best example that I can give you is like the land snails that you see. So they basically just like pull their long body and then they drag the shells behind. So in a very similar way, on the underside of the clam babies, they also have a foot, a very, very strong foot. So this foot basically extends outwards and pulls the shell forward. And then they just do that overnight. So what we've learned is that in the daytime, they would just stay put at wherever they are. They would probably just be staying put, gathering solar energy, growing and, gathering that energy. But they would start moving a lot more actively at night. So from a like reef life perspective, the daytime is very busy. Lots of predators around. But many of the same predators, they go to sleep at night. Of course, there are still many different predators at night as well. But for some reason, we don't know why, but they definitely chose to be more active during the evenings. So if you like to see how they walk,
do a night dive.
you can actually go on YouTube and then maybe just search for walking giant clams because one of our school university assignments, my friend actually uploaded 4 different separate videos about behavior. So one of them is like he had this really nice background music that's kind of like buzzing bees, but you'll see them kind of move around like buzzing bees as well. It's really exciting. Unfortunately, I couldn't find a video, so I didn't put it in this.
Also, like, there are quite a lot of them just like moving.
Yeah, so we did an experiment. So we would we lay them in rows and columns. And we thought like, they're not going to move very much. We know that they move, but we thought like it wouldn't be too much. But when we did an overnight filming, we were really surprised by how one individual walked from one end of the screen to the other end of the screen by the end of the day, by the end of 12 hours. It's really, so one of my friends actually painstakingly tracked each of the 108 clams that she has to measure which ones move the fastest and which one move the furthest.
Okay. So you would, yes, you have a question. So are they born with their shells or do they develop their shells?
Right. So if
how-
we look at this life cycle, the life they start off very similar to many of almost all organisms. There's an egg and a sperm, so they would become an embryo. They would hatch. So they will hatch into something like this, which we call a chocophore. It doesn't look very much. So even under a microscope, they just look like little spinners. But at this stage, they don't really have a shell. It's still pretty much like a soft sort of covering around them. Somehow or another, it's a term we use, metamorphose. They would basically turn themselves into this very early stage where they actually form shells already. So actually by 2 days, they would already have some form of preliminary shell. Not very hard, but they would over time become harder. So they're not born with it, but they would somehow have a trigger that tells them that I need to build shells. And they build it really fast. If we think about like how fast this stage goes to this stage, is within 24 to 36 hours.
Oh, that's fast. Yeah.
Right, so how do they actually really build these shells? So to my understanding is that they basically have a mechanism where they can tell its body to grow shells. So they would take in like the relevant materials, and one of them is basically carbonate and calcium as well.
So what do they actually feed on? I guess the nutrition is important as with like human beings as well. So in terms of like food, what do they actually feed on? Like maybe does it differ from when they're really young to when?
So actually when earlier on I talked about like they being solar powered. So that's one way of getting food. They get it through the microalgae. But actually when they are born or after they hatch, they actually don't have this microalgae yet. They have to try and get it from the open ocean or from the water column. So what they do is like around this stage, they would start to filter feed. Basically, they would just drink a lot of water and try and drink up all the possible algae that helps get the nutrients. And in that process, the useful ones, which can photosynthesize, would somehow stick to their bodies. They would stick inside their stomachs, and eventually, they start to, in a way, they farm the algae inside their body. Yeah. And then after farming, and then like basically the really colorful tissues that you see here are all the farmed algae. So it's a bit like, a clam keeping a farm of algae in their body. It's very useful if you think about it. I don't have to constantly feed if I have algae on my skin.
Yeah, true. So they photosynthesize the algae, helps the photosynthesis of basically, and it helps them to grow and transfers the energy
Directly.
So they're like a plant.
If you think about it, yes, they're very similar. So yeah, they're a little bit like a plant.
Okay.
Yeah.
Oh, that's
but they're still an animal.
Yeah. Oh, okay. Yes. So I read somewhere that that giant clams, they have different behavioral patterns. Like they have their own characters, a little bit like mammals. Can you explain? Is that true?
Well, having worked with them and spending most of my years actually sitting in tanks and cleaning them with toothbrushes, I can actually say that like they do have a little bit of a quirky character of their own.
Okay.
I mean, maybe not so much for myself, because after cleaning hundreds and thousands of them, like it's really like a really big routine. But I have colleagues who actually take time to name them. So he would like arrange them in a certain way so that he can call them like by different names. Yeah. And then every time he goes back, he will just call them by name and talk to them and stuff. So then sometimes so that's a really long ago story. But I think something more recent is that we recently received a donated giant clam from I would say parents who have kept her for 7 years. So they decided that she was too big for their aquarium tank. They were decommissioning it. So they were looking for someone to adopt her. So when I saw the photo, I thought she wasn't very big. I thought she was maybe no bigger than the size of this camera. So I was like, yeah, sure, we have space. But when she arrived,
she was like a meter long.
Yeah, she was as big as that laptop.
Oh dear.
Yeah. Okay. So that was one thing. And the other is that she started having very quirky behavior. So she wouldn't sit still on the platform that we give her. She will always somehow topple down and go down to the bottom of the tank. And then we basically call her Picky Princess. So like we don't know why. We have no idea. We've given her all the possible, most nicest tiles to sit on. And we even built a boundary around her, and she still managed to find her way down onto the bottom of the tank. So we realized that, okay, we're just going to leave her there because she just has her own character and she just refused to go with us, and we refuse to listen to her.
Okay. So they do have characters.
Some of them do, I think,
after all.
yeah.
Oh, that is so interesting. So I guess it's not only things with eyes, but do they have eyes?
They do have eyes. So
Yeah.
if we look at the next slide, maybe, something that I kind of did, it was really fun. It was a really fun activity. So I think there were a couple of years back on Twitter, there was something called Unscience My Animal. So I decided like, okay, sure, why not? I will just try and unscience it. So, kind of using very interesting terms, I suppose. Potty outlet, food inlet, you go
So
figure.
the potty outlet is different.
Yes, they have where they eat and where they poop is very different. So, but we'll get to there. So I think the question you were asking was eyes. So, I say that these are hundreds of spy cameras. So along the margin and actually across the soft tissue, they have many very primitive eyes. They're what we call pinholes. So they are very, very old school. If you think about it from a camera perspective, there's like pinhole cameras. So these are pretty much similar in terms of like the resolution, how well they can see. So they are mostly black and white. They could maybe make out a shape and a figure, a shadow, which is something. So that's the reason why when you put your hands over them, they would respond, because like it's basically casting a shadow over them. And that change in light, which is very, very minimal sometimes, especially under bright sunlight. It's amazing how they can still detect that very minor change to realize that, okay, there's something above me. I need to protect myself or be a bit cautious. If it swims by, okay, that's fine. Yeah.
I see. So they do have eyes and they do have an inlet and an outlet area. So yeah,
They do
sorry.
photosynthesis, but you say they also eat something?
They basically have two ways of feeding themselves. But the predominant one is definitely still photosynthesis. The reason for still having the other method of feeding, which is just gulping lots of water, is so that they can actually get other types of nutrients that are not, they are not produced by the algae inside the tissues. So some example could be metal elements or also calcium. So it's usually those types.
Okay.
Are these animals endangered? Yes. So that's also one of the motivations of why I'm studying them or why I continued my work with them. So I did mention briefly that like one of their biggest threat is actually humans and human activities. They are actually heavily fished. So not so much here in Singapore, even though we do have a small population of them. But just right next door, like in Malaysia, in Bintan, which is Indonesia, 2 hours away from us, there are actually people who are fishing them very actively and eating them. I mean, not surprising, right? Like we eat the small one, so this one can last you for a week decently. But like, with human populations going up, coastal populations going up, the more of them got fished out. So it's sort of like a cascade where people who used to feed on them sustainably, because populations have gone up, like, they are basically being overfished at like numbers that are really
unsustainable,
unsustainable.
fishing. I see. Okay. So people do consume these giant clams for as a food source in like the neighboring countries.
Yes.
Okay.
Yeah.
Interesting. Yeah.
Sorry, you said 500 million eggs they can produce?
Yes.
Yeah.
What's the survival rate?
Yeah. Survival rate of 500 million eggs is.
It's
1 in a million or what?
Yeah.
well, actually, 1 in a million would be great, but that's not it as well.
Wow.
Yeah, that's right.
That's really low.
Yeah. So when we saw that life cycle, like even getting the, if I may, just shift back to that previous slide, it'll be easy to see. So The numbers that I'm sharing with you are mostly from the lab because we do breed and culture them. So at this rate, at this stage of like fertilization, we do get really good numbers from 60% to 80% of whatever numbers of eggs that we have. So maybe for example, 5 million. And then the hatching rate, maybe we'll still get it about 40% or 30%. That's still pretty okay. But for some reason, between these two stages, there's a huge drop. So it can be a 90% loss of whatever that survived beforehand.
And that's in a lab condition.
Yes, exactly.
Ah,
Yeah, so
okay.
if we imagine that, like, if that's the lab condition, what's happening in the wild would be a lot more lower.
Yeah.
So the one or two individuals, like young individuals that I see on the reef are, makes me really happy because I know that like there's still hope, there's still chance. But I think we need to, for some populations, we need to lend them a helping hand.
Do you know why there's such a bottleneck for this step?
Yeah. So why is that bottleneck?
Right. So why would there be a bottleneck between here? I think it's something that we still cannot overcome. We're not entirely sure. But actually, having that sort of discussion about like that formation of that shell, it makes sense because like maybe some of them are just not ready or they don't have enough resources at this stage to really push themselves to this stage. To become this stage, like you need to form shells already. So the ones that really can do it are really the better ones. So usually we do see much better survival rates in from this stage onwards. Something that my boss laughs at me is that like we have more giant clams in our lab than what we have on our reef, which is true.
Okay.
Yeah, what we have in the reef is like no more than 100, but in the labs we keep them in thousands for now. But of course the numbers drop, but it's still a lot more than what you see in natural environments as well.
So are there, sorry, I'll let you. Yeah, so if they're so big, how do people actually swim, carry a giant clam and like move it out of water? It's like 250 kilos, right?
Yeah, sorry. Yeah, no, I mean, that's an excellent question if you're thinking of doing it. Or you're wondering how people do it, right? So there are two ways. So one is definitely still the old school way, carrying the entire animal up. Why? Maybe your question you asked me, why would they do that? Because the shells are really good as materials. They use them as like troughs. They use them to like, hold water for their farm animals. They use them as like materials to surround or protect the houses. So in some of the Pacific islands, they would basically, like an animal like this would need 4 or 5 strong men. And their boats are like, the really simple wooden boats. They would have very strong ropes. They would just, tie the animal and have like 4 people from beneath heave it up, 1 or 2 guys on the boat, balancing and trying to get the whole fella up. Yeah, so that's one way. The other way is a lot easier. The other way is basically just bring down a knife and then just kill it on the spot. And then you just, cut out the meat and you just carry the meat up. I mean, the meat is still pretty heavy, but it's a lot easier. So there's also, then for that, like, we see like mass graves of shells. Then we know that, it was, people just take the meat without the shells.
Yeah. So do they grow anywhere or is it at a particular spot of the reef?
So I'm generalizing this because apparently every species, so there's 12 species in this family, so every species has a little bit of a different behavior. But generally they are found on coral reefs. They love to be around coral reef areas, but we have seen them also on just bare surfaces or bare seabed as well. So something like this with very little corals, but you sort of get them sort of seating and surrounded by this. So that's my answer in that case. We used to have them.
Yeah.
Not this species. We used to have them.
So is this the giant clam species?
Yeah. Yeah. So this is the true giant clam. So to give it a bit more of like I guess his reputation. This is the true one. The rest are not.
The rest are fake giant clams.
Fake one. Yeah. But there are some interesting ones.
Okay,
Yeah.
cool. Yeah, sorry.
So I was wondering if there were any laws or restrictions on their fishing practices, like giant clam fishing practices.
So are there any laws or restrictions on giant clam fishing?
Yeah, no, that's a great question. If we're talking about Singapore, yes. So they are legally protected under the Wildlife Act right now. Something we've revised it, so now it's called the Wildlife Act. It has always actually been on the Wildlife Act. Just a sort of like one step background is that it's also because it follows very closely to the Convention for the Wildlife Trade of Species, so what we call CITES. And it has been on CITES Appendix 2 listing since 1986. And then Singapore's basically, from what I've seen on their on how they list animals, is that anything that's on CITES, they would actually put them on the Wildlife Act or the protection list as well. So giant clams have always been there. And in most places, like in Southeast Asia, they are also protected species. So the irony of it is the enforcement. The resources and the funding and the budgets needed to actually protect them in actuality is usually very difficult or challenging, depending on each country's situation, depending on each region's situation as well. So I think in Singapore's case, well, they are pretty hard to find because there are so few of them right now. I would say that only my team knows where to find them. But other than that, most people would just like, I don't know where they are. Like, I can't see them. You can probably just be walking by them and you don't realize them as well. But in elsewhere, people still fish them, even in protected areas. So then that's where, like, local community managers have that hard task of convincing them to not take them. Because there's no policing as well, because these are local community members. Imagine if they take one and they have to be fined, they have to be sent the paperwork, right? Who likes paperwork?
Yeah. Yeah, exactly.
So I mean, like, from an administrative perspective, it's very difficult to do enforcement. Not just casually like paperwork problems, but many other issues as well.
So it's you would say that the main issue of this is really enforcement towards farming or fishing them in a way from these communities that's causing them to be depleted in the wild.
Yeah, I think legislation and enforcement is definitely one weak area.
Yeah.
But I think it's also about people not understanding how much, like, to what extent can you fish them as well. So they're basically taking out resources they have some idea. To be really honest, I think the communities are aware that, like, if they take too much, they know that they're not going to have them anymore at some point in time. But they may not be able to appreciate, like, numbers. Like, you can't, in some communities, like in Japan, in South Japan, for example, they do have very strong community engagement. So actually what they did was they started, the government facility actually started culturing giant clams in large numbers. They would sell the seeds very cheaply to farmers. They would ask the farmers to just grow them, and then the ones that they grow out, they can actually take them for eating. So far, I think it's worked quite well, but there are different other challenges. It's not necessary, but it also somehow helps the natural population to recover as well. Especially it depends on how often the farmers take them out as food or as for sale as well. Yeah, it's one of the few places in the world that you can eat them legally in small numbers. Palau is another place as well, which I recently visited, where they are allowed to eat. You can eat it locally, can buy it from any of the restaurants. But they have very interesting laws, which makes me sort of mind-boggle as well. Yeah, so people are allowed to eat, but they don't actually. But Palau is also one of the few places in the world that have that capability of growing them in huge numbers. They're culturing them in masses, thousands and tens of thousands. When my colleague and I went there, we were like, this is a farm that we really want. But that aside is that they're also actively selling the seeds to farmers, and the farmers will grow them and they will eat them. But the irony is that like there are people still poaching not just from people who are culturing and growing them, but also poaching the wild ones. So then basically there's no
it's not
differentiation.
A stop gap. It doesn't stop anything. But is there a reason why? Oh, sorry.
So I mean, like I didn't stay long enough to ask about the legislation. I think that's a bit sensitive as well. But it was definitely like a very interesting takeaway from me is that like certain systems that we think like say in South, it works pretty well in South Japan, but may not necessarily work very well elsewhere because of different factors such as poverty is a little bit strong of a word, but basically low income. Because to buy them is still too expensive. It's just cheaper to steal from somebody's farm.
Yeah, I guess, when you don't spend any time or money culturing this, I guess so. Yeah, sorry, you had a question.
I have two questions. Do you all track the population of these clams in Singapore? And the other question is, how does it affect the ecosystem if these clams were to disappear?
Yeah, so very good questions. I think, so the first question is how I guess the ecological aspect of it.
So no, that's a great question because like somewhere midway in my PhD I also asked myself the question is like, why should people care about them, right? They're just like, they look like rocks, to be honest. Sometimes people laugh at corals, but sometimes I laugh at clams at being like rocks as well. So actually I basically did a deep dive into like searching for information, searching for research that really talks about like what kind of ecological roles they play on reefs. So we talked a little bit about certain things, how they're food sources for certain animals, in a way sustainable food source. You keep them alive around long enough, fishes can have continuous food supply, and many other things as well. And an animal like this picture might not do justice to it, but in certain places, their shells are fully covered with other animals. They're amazing. It's like it's almost like a mini condominium here. So if I think about it, you think about it as like a HDB or a mini condominium. So in Singapore, I use HDB. But you think about it, like the inside is so big, so there are animals that live inside the cavities, and outside is like, the shells. They're just really great surfaces. And an animal so big, it's almost like a bodyguard. Nobody dares to come by or come near them. And because, also like, greater ecological roles such as like contributing to the the carbonate. So we know that coral reefs are the framework. Corals are the foundation or the frameworks for coral reefs. But very little attention has been given to animals that build calcium carbonate in such large quantities as well. So it's one of the few animals that can build so much calcium carbonate over its lifetime. So even after it dies, the shells would live and stay on the reef and become part of the reef as well. So going back to the question on like whether we monitor them, yes, we do. We try our best. And in fact, it's something that I'm really proud of. So ever since I started my PhD, so that was almost 15 years ago. So I'm actually no longer a giant clam girl. I should be upgraded. But anyway, jokes aside, through that project, I worked very closely with a group of citizen scientists. They're part of the Wow Singapore group. And even after my PhD, they were still locating and looking for giant clams. It almost felt like the clam became part of their routine to like, I must look for one. And anywhere they go, they would, any reef they go, they would actually take photographs. It's very funny. If you go onto my Facebook, if you had a chance, all my photographs tagged.
Giant clams?
Yeah. So when they tag Mei Lin, it's not my face. It's always a giant clam. Yeah. So most of them, I have to say
Yeah.
80% to 90% of them. But I think it's really heartwarming to see how an animal like this, like during that short 1 year that I did that PhD project with them and engagement with them, that they've taken it up so much so that even the new volunteers who join them, they would also be looking out for them because they know that these are important animals. We don't have many of them. It's good to know where they are and how they're doing because they actually can also tell us how reefs are doing as well. If we lose them, it means that probably something's wrong with the reef as well, and we should be actually paying more attention.
So they are one of the bio indicators for the reef, the health of the reef, right?
Yes, that's
as
what I
well?
would say. Yeah.
Okay, so because I guess as with wildlife on land, terrestrial wildlife, they're all the larger mammals are always seen as the bioengineers. So would we say that this is the equivalent of a bioengineer for the reef?
Yeah, I would think so. So, they're like what we call ecosystem engineers.
Yeah.
From a reef level perspective.
Okay.
So they are engineered in different ways. They can modify the area. They can create new spaces. And their very existence is also engineering something.
Yeah, different things. Nice.
Yeah.
Programs available for us to like play a part in this.
Yeah. Good
I know.
question. Yeah.
Yeah, I always get that question on what can people do and how they can help with our research. A couple of years ago when we have a larger scale restocking program, I was able to actually engage with some volunteers to come help either during the diving where they go down with me, they would monitor and look at the giant clams that we put out on the reef, or they come to the lab and help brush clams. These are all very helpful. But right now, I think I have to say that I have so much enthusiasm from even student volunteers and interns that I'm not able to take a lot more volunteers. I wish I could. I wish I had this huge farm where I could just engage people with them and talk about them. But hopefully that will come soon. There is some discussions going on, so stay tuned, and hopefully I cross my fingers, and hopefully there'll be opportunities where you can just look at them, work with them as well in the near future.
Where do people have to stay tuned to in order to find out more about these opportunities?
Oh, good question. There isn't a fixed page, but I do use my own Instagram to share about different things, different opportunities. I think you can also stay tuned to the St. John's Island National Marine Lab. Sometimes we would also put up workshops or interesting events or volunteer work as well. So for example, currently right now, one of the programs, actually there are two programs, not related to clams, but one of them is looking at coral reef restoration. So if you're a diver, you're interested, you could look up like WWF Singapore. They are actually in the process of doing coral reef restoration work with volunteers. The other would be the biodiversity surveys with the Sea Aquarium in Sentosa. So they're doing surveys. So there's an expedition coming up in May. So I think they do still train volunteers and look for new volunteers to come and join them.
Nice.
Yeah.
So I guess these are some of the good ways we can kind of be a part of this research program, I guess, to kind of look at the health of our reefs and to contribute towards the biodiversity data that we gather. So actually I do have a question about the brushing of the shells. So why do you have to brush the shells? Oh, okay, was that your question? Yeah.
So if you put them on a reef, they have natural algae feeders, they would just naturally graze on their shells and make sure their shells don't overgrow with algae. So in the laboratory, especially when they're so small, just very tiny strings of algae can actually get trapped and entangle them. So they would actually just end up being closed, so they are unable to open. So they're a little bit they're definitely babies for sure. So basically that gentle brushing would remove the algae so that we could basically just let them grow better. But of course, after a certain age, the brushing frequency becomes lower. We want them to build their own resilience. There you go. Why we brush them.
Okay. Yeah. Yes. Yeah, so is that...
So is algae overgrowth one of the problems? I would say yes. So very interestingly, even though in the laboratory setting, we also have seasonal growths and bouts of algae. So we have some really nasty ones that we need to do it like 3 times a week. But we have some that doesn't grow so fast, so maybe once or twice a week is fine. But when it comes to the really nasty ones, like sometimes they are a little bit toxic as well. So then they can release toxins that will not be very great for the animals as well. So these are a little bit hard to manage because, you know, in a tank system, we're kind of limited unless we are able to change tanks for them or change a space for them.
Yeah. Oh, okay. That's very interesting. Yeah.
May not be related, but do you know of any terrestrial volunteering opportunities?
Terrestrial volunteering opportunities. Yeah.
Yeah, I think you do join quite a bit, right?
Yeah,
Yeah, unfortunately, I'm definitely much more aquatic. But I think, there are... I'm not sure whether they're still active. So I know that there was a period where Jane Goodall Institute has a very active
Monkey guarding.
monkey guarding with Andy and Sabrina. So I'm not sure if they're still actively training volunteers on how to do human-wildlife conflict.
Yeah.
Then I think...
Swag. So swag is...
I think definitely Bear probably knows a lot
Singapore
more.
Wildcat Action Group is another organization. It's also a non-profit that a few of us here represent. So we're all volunteers with SWAG. SWAG is a fully non-profit volunteer-run organization. We do wildcat conservation. So we do mainly Malayan tiger conservation, and we also do leopard cat, the mainland leopard cat in Singapore. So that's our last wildcat in Singapore. We do only have about less than 50 of them left in the wild in Singapore. So they are critically endangered here, not in Southeast Asia. So we run a couple, I think Marcus is going to run a survey very soon. So if you're keen, we're looking for volunteers to take part in helping to do some camera trapping work, walking the transects. Yeah, so we can definitely get you on board on that. Yeah, so if you guys are keen, yeah, so swag, follow swag. Shameless plug, but Singapore Wildcat Action Group. SWAG. Yeah, correct, that's right. But let's return back to the topic of marine science now. Actually, I've got one question about people buy pearls, right?
Oh.
So do they have pearls, and how do these pearls come about, and is it like the bigger the clam, the bigger the pearl?
Well, firstly, I think we need to acknowledge that pearls are irritants for these animals. So pearls are things that they don't want, but pearls are things that we want. So that's a bit of an irony. They desperately want to spit out whatever foreign objects in their bodies. So the answer is yes. There are some recorded pearls formed from these animals. So it's usually from the inside of the shells. So it's only after the animal's dead, then you kind of see this very huge blister inside the shell. It doesn't look anything nice like the pearls that we have. Those are really properly cultured. But even when they say culture, basically the idea is to insert a really small particle into a part of the body where the animal will know that it's a foreign object. So it will constantly form nacre, which is the material of pearl, over it. And eventually when they extract it, they would just polish it and it looks beautiful like a pearl. But it's basically something that these clams don't want.
I see. Okay. So they actually do have to kind of culture it, and you have to kill the clam in order to get the pearl.
Yeah.
I see.
Yep.
Okay.
Yes.
Right. Yes. Sorry, I thought I saw a hand just now. No? Okay. Yeah. Maybe you could tell us a little bit more about your day-to-day job on the island. Just now I was very afraid that, I was like, oh, it's raining. Is she going to even make it? Yeah. So if you could kind of share about she does not work on this island, by the way.
I don't work in this really nice fancy place. So actually, my workplace is really interesting. So there's a daily commute by boat. So people take train, people take bus, I take the boat as well. So the marine station that I work on is located offshore on St. John's Island. So it's an island where public can go as well. You can take a public ferry from Marina South Pier, and you can enjoy the islands. But the laboratory is definitely out of bounds. There is an open space for public, but the laboratory side and aquarium side are out of bounds for public members. So yeah, we have to basically bring our food every day. We basically have a very, very fixed working hours, 8:15 to 5:15. So don't be late for boats. For either sides, otherwise you get stuck. Yes. So rain or shine, actually rain or shine, boats go as well. So basically it's a daily commute to work. My current work routine is very boring because over the years I've also grown in my career, so I'm mostly supervising projects right now that my colleagues do. But when I do get that chance to hang out with them, I will go out to the field, either scuba diving or intertidal reef walks. We'll actually look at clams, monitor them, locate them, think of ways like how can we find a clam, on the reef, and back in the lab, sometimes we would just how is this clam doing? What is she doing right now? Have that sort of discussions with my colleagues. In fact, actually, that's one of the most common things because they're always asking me, Mei Lin, is this clam okay? She kind of crinkly. Is she sick? Do you think I have to do something? I'm like, wow, I really feel like a clam doctor.
How do you tell if a clam is sick?
Yeah, I know. So they may have eyes, they may have mouths, but not quite like the way that you think. We basically have to rely on many different behavior, different sort of features to actually try and get an idea. Especially after they've been with us for a long time, then you sort of get to know them a little bit better in that sense. But one of the things that we always look out for, which is actually quite clear in this picture, which is you could see that as it kind of squirts out this cloud, which is actually a cloud of sperm, by the way. So that's how they spawn. You can see that the margin of the shell is very white, very clear white. So that's an indication that the animal's growing pretty well. So one of the things is that if the shells are clean, which means that they are actually able to constantly be growing, and they are able to deter algae as well. Once the margin is covered with algae, we can get an idea that, okay, this individual's not doing so well. Either is it because it's old, or maybe something's wrong with the environment, or something's wrong with it as well.
That's basically a male clam and a female.
Okay, so going back to one thing that Daphne
Male
asked.
or female clam?
What do y'all think? Male and female, or male or female? They are both, yes. So they're one of the special ones where we call them simultaneous hermaphrodites. So simultaneous, we know, same time. Hermaphrodites means that they have both male and female sex organs inside their body at the same time. But when reproduction, they don't release both at the same time. So usually when we do breeding, we would basically see clouds of sperm first. So this we know that, okay, they're releasing sperm. Sorry. Maybe about half an hour to 45 minutes later, we will start to see the eggs being released.
By the same plant. Okay.
The eggs is also being spread out in this form.
Yes, so in a natural environment, if there's no interference or no intervention, they would naturally spawn in the water column, and then basically let the waves and currents decide fertilization. Whereas in the laboratory setting, we would collect them in separate pails, then we would do artificial insemination. Think of it sort of that way. We're basically reproduction doctors as well.
How do you collect them if they're just squirting it out? So you just use a bag? I don't know.
Those were good old days. I got squirted so many times. I smell sperm water every time after each spawning. So no, this is perfectly beautiful. If you're underwater, using a bag is the great idea. You just put it over them and then you just collect 1 or 2 bags. Because this is pretty dense. You don't need so much sperm. But you want to collect as many eggs as possible. So anyway, people would collect them in this setting, and then they would bring it up to the boat, and then they would do fertilization. But in the laboratory, we don't have something like that. So we would put them in really shallow waters, and then they would just like squirt a huge jet of water out. So when I
into
first
the air.
yeah, out of air, so out of water. So like at that time when I was learning, my colleagues say like, yeah, just use a pail. I'm like, no, what's that? No, it's not a pail.
Plastic bag.
It's the scooper.
Oh.
You know the water scoop
yeah,
that you
like a
use to
squirt.
shower?
Yeah.
Yeah, that one.
What?
So it's almost like a
It's
game
like-
of catch.
So after they squirt, you run around with
Yeah,
a pail?
so you have to make sure like you aim, then you just catch like that. Of course you don't catch a lot. It's like usually very little. So you have to like collect a few times. But it's quite funny.
Do they
But
only squirt one jet or multiple times?
it'll be sequential. But it could be a few times before the eggs are released. Fortunately for us, eggs are not released so violently,
Okay.
so we could collect the eggs a lot easier in the pail, in the bucket, where they sit. But for sperm, we do that catching, that catching.
Are the
water.
eggs also released in this manner?
Not so violently, but they would just
Also-
slowly get released.
Okay.
Yeah.
500 million in one time, or is it over the life?
So I think for that particular record was a single individual in one event. Yeah, but an individual can release a lot less than that. So it
it's
doesn't
not
have to.
always 500 million.
Yeah.
Okay.
Yes.
On that foot, so does that mean that they have low genetic diversity? I mean, in which case will you down the line, will you see any form of genetic deformities? Yeah.
That's a really good question. Yeah, so is there genetic deformation because of the hermaphrodites and reduction in genetic diversity over time?
Yeah, no, that's an excellent question. Because if you think that they are like hermaphrodites, that means they can self-fertilize. I think that's the motivation of the question, is that this sperm can fertilize the same eggs. But that's an interesting thing. So if you think about the process, and if you think of it from a natural environment perspective, the sperm water would get washed away eons ago already. So the moment this comes out, it gets washes away very quickly. So there's nearly no more sperm in the environment. So by the time when the eggs come out,
Yeah.
the eggs would more or less be fertilized by other sperm donors around them.
Okay.
Yeah. So actually it's a bit more complex. So I'm not telling the whole story. So this individual, hopefully nearby it, no more than 5 meters,
There's
they
another
have,
one.
they have many of them. And something interesting that we learned is that the sperm water doesn't trigger spawning in other individuals, but the egg water does. So you think of it from a sequential perspective. If this guy releases eggs and it triggers spawning in others, the others will give sperm first, and that's how it gets fertilized.
Okay.
Yeah. So in the wild, we think that this is how it works. And there's only been a handful of observations, so very, very difficult to tell. But in the laboratory, that it is a concern of genetic inbreeding, because in the lab we can control. And to some extent, some individuals are more likely to always give eggs than sperm. So we would more likely get more mums from the same individual than dads. So even though there's many different dads, but if you think about it, it is still somewhat of an inbreeding, because we only have one female donor.
Are they all bred in the same pail tank or?
Yeah, so we have different setups. So sometimes we put them all together. We try and get them to all spawn.
Spawn, yeah.
And then we try and then we separate them. Also, if we have the resources, they would all be in different containers. Yeah.
Oh, okay.
How often do they
Yeah. Spawn. Yeah.
Yeah, so how often do they reproduce? In the wild, we have, as I say, very few observations, so there's no pattern. We can't tell what the pattern is. There have been many studies that basically did it indirectly by injecting a really long hypodermic needle to actually extract the materials that they find in the sexual organs at that point in time. So every month, they basically measure how much of it is eggs, how much of it is sperm. So they basically look at the maturity. And I think depending on which population, so for instance in Australia, mostly in the summer, the eggs are viable. So then they predict that spawning could happen, but they don't necessarily observe it. So it's not quite like, in fact, actually many invertebrates, we don't really know when they do their reproduction. We use this indirect method to give us an idea. It's helpful for laboratory work, but not so much in the wild. So it doesn't quite match.
How about in the laboratory?
Laboratory so far, we can spawn them nearly every month.
Oh, okay.
Yeah, we found, at least that's what we found. But we don't exhaust them.
Yeah. Do they get exhausted? Can they? Do you-
Yeah, there are. So basically they're using the same approach. They have seen that there are periods where they are completely exhausted, no supply.
Okay.
So we know that like there are periods where they completely
just have nothing
inside the organs. Yeah.
Okay, that's very interesting. Okay, I'm very mindful about time, but I do want to talk a little bit more about your work with Mothers in Science. Maybe could you share a little bit more, because I think just women in science in general, I do feel like there is a bit of a, I guess, stigma about hiring someone who has to go outfield and then she's like pregnant, she can't go outfield, what do I do? So could you, I guess, share a bit more about that?
Yeah. So I'm a mom of 2 girls right now. 5 and 2. And when So for us, I think we didn't quite do family planning. So we didn't know when we wanted to start a family and stuff. So when I eventually fell pregnant with my first pregnancy, I found myself in a huge dilemma. Because I was at that point in time in my career, I was trying to build it, trying to go to different places, get collaboration. So I was really hustling as much as I can. And when I found out that I was pregnant, I actually became a little bit depressed because I thought to myself that I'm no longer useful. I'm no longer able to be able to dive. I'm not able to do my work. A very negative thinking, I have to say. I really spiraled down in that sense. And to some extent, I disliked the fact that I was, pregnant at that time. So when we lost our first baby, I think that's when I really changed my mindset. So I went through a really period of depression. Let's not go down that route. But I think it really sort of changed my perspective. And that's when I also started to actively try and read up as much more about what it's like to be a mom who does field work, or what it's like to be a field biologist mom. So when I became pregnant with our first child, after, that's when I became very anxious. So being Singaporean, very kiasu, very kanchiong, really, really. Then somehow, I can't quite remember, but I basically met Isabel, who is currently our CEO and co-founder of Mothers in Science. And what's really interesting about our organization is that we completely form ourselves online. We've never met each other in person, not yet.
Wow.
Yeah, if there's opportunities, especially because they're mostly in Europe and North America, then they have more opportunities to see each other. But I've never met my co-founder and many other members that I worked with. But I think that was really what connected me with them so much, because we may be far apart, but we share same stories, we share same problems. Amongst our teams, we have people who are also very similar to me. And I realized that what I really wanted was someone like me, a role model. So at that time when I was pregnant on both instances, I didn't have someone that I could look to see similarities or ask for help or ask for advice. So but I put in a lot more effort after that as well. And then later on I realized that I could be that someone as well. So some years down the road, we're about four now, five coming 5 years now. I do my best to actually raise the visibility and I know it's just casually saying raising awareness, but I think it's also sometimes finding that opportunity and nooks and crannies to actually do something. So I think one thing that I was really proud is that maybe my younger female colleagues or my younger colleagues may not understand, like, why is there a need for a family room? Why is there a need to like have a nursing pod? Or why is there a need to be family friendly for an international conference? But because of my work with them and how my interactions with them, I realized that, look, someone has to start this conversation. Someone has to do something about it. And right now, last year, I had that opportunity. I was in a position where I could ask my chairman, the committee chairman, and say like, look, I want to do this. And I was really the only one doing this. Maybe because I'm not saying anything, but I'm saying that like perhaps the younger peers, they're not sure what to do, so they're not sure what they need, right? So that's when I connected with other people. I connected with Go Mama, which is basically a mobile lactation pod. So I'm really glad that I met Vivian. She was so helpful. She was very supportive. She was willing to actually also just let the pod be there, just for visibility. But I think what really came out of it was parents who used the space and then giving the feedback saying that, look, this is really helpful. If it wasn't for this space, I wouldn't know whether I would come for the conference. And that's exactly something that I would face as a problem. As a mom, if I want to go for a conference, but I want to bring my child because difficulties, or I just want my child closer to me. But if a conference wasn't going to be friendly, I'm not going to be able to support it. I'm not being be able to do science, that's one thing. And I'm not going to be able to, support my child at the same time. And that actually becomes, that's something what we, many times, not just scientist moms, but many moms as well, working moms, is mom guilt. It just makes you feel guilty, not taking care of a child, but work guilt as well. So how do we actually come to a compromise or consensus in that? Is to really show others that these issues really matter, regardless of where you are, regardless of what field you are.
So really, thank you for bringing this up, because what do you think are some of the ways in which, I guess, in terms of like organizations that you see lacking? I think I do feel like somehow in Singapore especially, I think we have quite a traditional mindset about most things. Are we lacking, or do you think we have, I'm sure we have improved over time, and maybe if you had a wish list of doing something at your workplace, what would be some of the things that you would change?
Yeah, I think the timing is kind of, everything's kind of coming into place. I think when I gave birth to my first daughter, I was struggling to find a private space in the laboratory in my office to pump or to feed or to nurse. It was embarrassing. I had to book a meeting room, try and close all the windows and everything, and do that in privacy. It wasn't a norm, but I just pushed my boundaries. I pushed it. I pushed it by trying to see like how my colleagues would react. Would they get annoyed? Would they get irritated? And as I slowly pushed the boundaries, I come to realize that maybe it's just my community, but I think it's worth figuring out if it also applies to a wider community. But everyone was really helpful. So when I had to bring my child for a meeting, some of you might know Siva Soti, who does international coastal cleanup. He was like, yeah, sure, bring her. And she literally sat through, but she was very quiet. I don't know why. She was really very quiet. And everyone was just amazed by like me with my child, 3 months old, sitting in a meeting. So my mind was like code switching, right? I was like, okay, how's my child doing? Okay, I'm talking about something about work. So they gave me a safe space to actually try. And over the years, I just keep doing it. Over the time when she was growing up, she followed me in almost everywhere. And when I had to go toilet, like my colleague would be like, yeah, sure, just go. Like I can take care of her. I was like, oh, okay. I wouldn't know if I didn't try. I wouldn't know if I didn't give them that opportunity to let me know that they're supportive of me, of being a mom, a working mom. And I think over the years, it's been like that. I bring my girls to my work office and I let them get to know everybody who has been a critical part of my career, who has been helpful not just when I'm away, but have been helming and running everything when I'm away.
Oh, fantastic.
Yeah, which I think is very important because them actually being girls as well, I hope that when they grow up, they will also be able to reflect that in their own family life in the future.
Yeah, sure. I do think like especially they're young and impressionable. I think a good and safe space to kind of grow up in and having a figurehead to look up to is important. Like I guess in all our workplaces as well, I think having a great mentor or a safe space, basically, it's very important. Yeah, thanks for sharing about mothers in science because
no
I
problem.
never knew about that. Yeah, and I think supporting more women in also in the field of science and technology and medicine is also a great way to support women in this field. Yeah, we are. I know that we have a lot more questions because I'm actually only halfway through my own list. But we can talk to Mei Lin more after this conversation. I just want to have everyone have a bit more time to kind of mingle and talk to each other, have more food. Yeah, so I will close with just one more question. Maybe can you give us a takeaway after hearing these issues about giant clams? Maybe just a personal takeaway for.
No, I think firstly, thanks everyone for your enthusiasm for asking the questions because I think over the years, like it's everyone who's been with me in different arenas, different events, asking me that question that kind of keeps me motivated to and inspired actually to continue the work that I do, to actually continue to discover something interesting about them, but also be able to have that opportunity to share science with everyone. So as a scientist myself, one of the things that I truly appreciate is science communication and really bridging that sort of gap between the wider audience and science as well. That science can be fun, right? Like we were learning about an animal that we've never seen before. Hopefully you'll get a chance in the near future to see it yourself and play around with them, figure them out. But I think that's actually basically about curiosity and being about this wondrous ocean. And we need more people to know about it so that we can do our part to actually protect this important resource, which is we know that it's declining, we know that it's not doing very well. We can make hopefully through seeing is believing and seeing is also understanding and being respectful, and with that comes with change our behavior and change our mindset. There's nothing that I say today, insisting that you don't eat clams will make you change your mind about clams. Honestly, it is. So let me tell you something that's about myself, is that after working with them, I have not eaten clams for a really, really long time.
Oh.
Yeah. I might accidentally eat them, but then I was like, okay, that's because it's there. Okay, I don't waste food, so I just take them. But I really make a very strong discerning choice to not eat them, not eat any kinds of clams, and not just because they are friends, but the very reason is because I work with them and I see them as my friends right now. And they've been really good to me in many different ways. They've been really not just my career but personal level as well. So because of that, I made that choice 15 years ago. And hopefully if you guys have the opportunity to immerse yourself in something like this, you will eventually make that same choice and make that same decision yourself without me pushing people, right?
Yeah.
I think you have a very meaningful job. Does your lab have any open house to let the public know what exactly you guys are doing?
The open house tour of your lab. That was something I actually asked for, but I couldn't get it as well.
Or some promotion,
Wait.
what
Shamin, Joel, do y'all ever come to our open house? Have, right? Okay, but it's only once in 10 years. We have a lot of that feedback, especially when we did there are only 2 open houses. So 20 years ago and 10 years ago and just last year. Yeah. We did our best to promote about the event. And we and last year, so the first year when we did it, we invited a lot of our own relatives and family, because actually even our own family members don't know what we're doing. So it was a very great opportunity for families and relatives and very close friends to come and visit our lab. So we had a really great open day. But last year was a lot more meaningful for me because we didn't just invited our own families, but we invited as many public members that we've never met before. So many of times, for events like this, we would be always seeing like familiar faces, people that we know from different events and activities. But I think last year when I was hosting it, I realized that there were so many people that I didn't see. In fact, when I casually asked my my children's childcare teachers to come, two of them came. Two of them came and they were amazed. And Ada was with me. She was sitting behind, very quiet and very good girl. The teachers were impressed that like, wow, she really just sit there and listen, waiting for her mommy and doing her own things. While I was doing work, while I was hosting, while I was like having explanations. So yes, we have that. At least our lab, we do try to go to as many different events. So sometimes the major ones like ADEX is coming up, so that's the Asia Dive Expo. So that's an event where we sometimes are invited to have a booth. We also try to, or some of my colleagues are very present during Festival of Biodiversity that happens every May. So there are actually activities that we do try our best to do it. But for the marine lab per se, I will send my feedback to my colleagues and see if we can do something about
That
it.
would be nice, yeah. We'll let you guys know if we actually manage to do that, and then we'll invite everyone again. Okay, so in lieu of time, I will wrap up this conversation with a couple of things. So the first thing is actually I really wanted to talk about the microplastics that she is working on now, which we can talk to her about it after this, because I do find that the first thing that really draws us to the oceans is also trying to keep it clean and making sure that the plastics don't end up there becoming microplastics that these clams or fishes that we consume will also consume. And this is saying yes to less trash, and this brings me to inviting our guests from Clean and Green Singapore who are here with us today. They're at the back, and that's why their poster is there. They've got 3 questions for you guys, and they have prizes too. And it's very easy. Oh no, it's okay. Yeah. Oh, you need to come here because you need the mic. So you have to come over. Yeah.
It's for the live stream.
It's for the live stream. Yeah. Okay. Yay. So yeah, answer these questions. It's about your daily habits as well. Yeah.
Thank you so much, Daphne. And thank you, Mei Lin, for the sharing. I think it's really, I think I speak for all of us when...
Oh, okay. Sit down so that the camera can see you.
Yeah, so I think I speak for all of us when I say that we really learn a lot. Correct? I think everyone learned a lot. So I think why don't you just give her a round of applause. Yeah, thank you so much. All right, so I'm from NEA. My name is Paul, and that's my colleague Charmaine. So so we are here because we actually so at NEA we have quite a few campaigns lah, and one of the main campaigns that we have is Say Yes to Waste Less. So you can take a look at the poster over there. So Say Yes to Waste Less. So just a quick question: how many of y'all have been to Pulau Semakau, or do y'all know where Pulau Semakau is? Anyone? Yes.
Who knows?
Who knows where's Pulau Semakau? I think you can't answer that. Yeah. So Pulau Semakau is where we basically, it's a landfill, right? So it's basically where we throw our waste, throw our trash. And just a shameless plug, if you all want to have
Sign
a
up
tour
for
of
Pulau
Pulau Semakau, sign up with
Yeah, we are
Space.
running a tour to Pulau Semakau
Yes.
on the 29th of February. It is a Thursday because it's only open kind of on weekdays. There is one weekend, but it's quite hard to get a slot. But you have to take half-day leave, 1 p.m. to 4 p.m. But it's a leap year, so technically we shouldn't be working. So do come. You can find it on our website. So yeah, do sign up.
Yeah. So we encourage you all to, if you've never been before, it's really an experience that you should try, at least once. Yeah. So you can just sign up with Wild Space. Yeah. So just a quick question before I actually go to the main questions. How many kilograms of disposables do you think we dispose of in a day? Anyone? You can just throw a number out. How many kilograms? 10,000. Anyone else? 400,000. Okay, we actually dispose 550,000 kilograms of disposables. How about food? Food waste. Anyone? A number? 1 million?
1 million.
Okay, the correct answer is 2.2 million kilograms.
Wow, that's a lot of
Yeah,
food.
per day. So it's really a lot of waste. food waste and disposables. Yeah. So as you can see in our posters, all these trash, all this rubbish, it actually goes into the landfill. And so the easiest way to reduce waste is of course to reduce the amount that we throw. Right? It's quite simple. It's not that hard to understand. So so how do we do that? That's the whole concept of say yes to waste less. Basically, not just in terms of food wastage, but also in terms of like our disposables, cutlery or disposable plastics, so on and so forth. Yeah, because it affects also like what Daphne mentioned just now. Also, it affects the environment. If all these disposable plastics or that if they end up in the sea, then it's gonna affect a lot of wildlife, ecosystems and all that. So yeah, so with that background, I'd just like to ask you all 3 simple questions. So like what she said, you will get prizes. Charmaine, if you can. So this is a limited edition, very, very cute Captain Green keychain. Yeah. I mean, it's open to everyone to answer. Yeah. Okay. So the first question. So if you don't know the answer, you all can just raise your hand. So how can we reduce waste when grocery shopping? Anyone?
Wow. Okay. Just now,
Okay,
I saw her
yeah.
hand first. Oh yeah, okay, you pick.
Sorry? Yes.
Bring
okay,
your own
very
bag.
good. Yeah, okay, so that's the
Wow.
right answer. So that is one of the ways that we can do it, right? So when we use reusable carrier bags instead of disposable single-use bags, that is one way in which we can reduce waste. Also, we can basically make a shopping list, and keep to that shopping list. I know sometimes it's quite hard because when you go to the supermarket and you just see things, you want to buy things that you don't even know you need. Yeah, so keep to the shopping list, and that's one way which you can reduce waste when you do grocery shopping. Okay, how about next question? How can we reduce waste at home?
Ooh.
Anyone?
Okay.
Yes.
For like canned products, you check the expiry date often, so you waste the food.
Yes. Okay, so that's a very good answer actually. Yeah, why not give her a round of applause? Yeah, so actually on that note, that's actually a very good point because a lot of people we don't check the expiry. Or we buy food and then we leave it in the fridge or we leave it in the cabinet and we just totally forget about it. And then 1 year, 2 years later you realize, hey, I have this,
Expired food.
and you think it's expired and you throw it away. But actually, just a fun fact. When they put best before, technically, it may still be edible lah. So you got to. I mean, best is you just consume it before the expiry date. But just because it's past the expiry date doesn't mean that it's bad. Yeah. So it's just something to keep in mind. I mean, we do have partners who actually collect all these near expiry date foods, and then they actually in that sense they resell it for cheaper, and people actually purchase them, and that helps in reducing waste as well.
Oh,
Yeah.
that's great.
So the last question, I'm not sure whether anyone will get this, but does anyone know why our mascot is Captain Green? Why is it a frog? Any
Ooh.
guesses?
Okay, wild guess, guys.
Anyone? Frog is quite sensitive to its surrounding environment. Okay. Yes, that's actually the correct answer.
Wow.
Really sorry. That's a very good, yeah. Correct. So basically Captain Green is a frog. And frogs are, as amphibians, they are sensitive to their surroundings, their environment. And in the same way we should be sensitive to our environment, right? Our environment is, you can see our earth is climate change, everything. The earth is dying. And basically we need all of us to really, put in effort to protect our environment and just, so say yes to waste less. Yeah. So thank you so much, everyone. Yeah, appreciate it.
Yeah.
Thanks, man.
Yeah, sure. Thanks. Yeah, so thanks everyone. We have reached the end of our conversation for today. I think Mei Lin, us, we're still here. If you guys are free, just stick around, mingle, chat. Our next conversation will happen at the end of February, actually the second last week of February, because on the 29th, where are we going? We're going to Pulau Semakau. That's why.
29 we're not working.
Oh yeah, we're going to the island. So yes, do join us at Pulau Semakau for the trip. It'll be really fun to know about how Singapore, what do we do with our waste, And I think seeing that will make an impact in your life, in the way you buy things, in the way you throw things, and in the way you consume things. So yes, please join us in that. We will be posting more updates on our social media and on our website. So do follow us. We are at _wildspace, and on our website is wildspace.sg. And to follow Mei Lin, she's at Clam Scientist. Yeah, so you can for more updates or more clam updates. Yeah. Okay. So So besides that, do we have a? Oh yeah. Okay. We have a guest book here. It's of a native wildlife that we'd like everyone to kind of like leave us a message and sign. We hope to make this into an exhibition at some point. So at all our events, we collect like writings, notes, signatures, etc. And we hope to make this into an exhibition at some point. So please do write that on your way out. And also, yeah, I think that's about it. So stay wacky, wild, and curious, and hope to see you next time. Thank you, guys.